Hello future engineers, welcome to my YouTube channel. If you are still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is problem example 24, still on resultant of concurrent coplanar forces. Determine the required tension in cable AC knowing that the resultant of the three forces exerted at point C of boom BC is vertical, and let R be the corresponding magnitude of the resultant. So here is the given figure. So if we draw a horizontal line here, the angle that the cable AC makes with the horizontal would be 90 minus 65 or 25 degrees. So as shown, so we'll call the tension in AC as T. Then this is 25, 90 minus 65 degrees. Then this is the direction of the resultant. Since the resultant is expected to be downward, because these are the action forces, the tension is just, these are the directly applied forces and the tension will just react. So the resultant would be directed downward. So that means Rx is 0. So that's the analysis. There's no X component of this resultant, and Ry is simply R. And it is equal to the X component of 375, which is 375 sine of 30, then minus the X component of tension, which is T cosine of 25. The 250 Newton force has no X component. So from here, we can solve for the tension. It is equal to 206.9 Newtons. Then knowing the tension, summation forces Y, Ry equals R, as shown. So it is equal to, this is the only force that has positive component. So T 206.9 sine of 25 degrees. Then minus 250 minus 375 cosine 30 degrees. So the R is equal to negative 487.3, but since we are just asked for the magnitude, it is 487.3 newtons. The negative sign indicates that it is really downward. Then for your part, determine that the required tension in cable AC knowing that the resultant of the three forces exerted at point C o boom BC is directed along boom BC, the corresponding magnitude of the resultant. So the resultant will be directed here. So meaning there is no component of the resultant perpendicular to boom BC. So that's your uh, problem for that case. And show that the tension is equal to 531.2 newtons and the resultant is 457. The magnitude of the resultant is 457.3 newtons. So that's it for your part.